Assalamualaikum warahmatullahi wabarakatuh to my panelists and to those who be my viewer at my channel for the first time. Okay, Assalamualaikum warahmatullahi wabarakatuh to my panel, Prof. Zali and Cik Fauzi bin Abu Hassan. Okay, today I'm going to present my last presentation in UTKL MSI 2020, which is for my FYP project. And the topic is the development of V2V communication system using Wi-Fi, also known as Light Fidelity Technology. Before that, my name Lutfil Hadi bin Idris. I'm taking course Bachelor of Engineering Technology in Mechatronic and being supervised by Madam Nur Zalina binti Othman. Sorry, and she do big help for me to make this project succeed. Okay, now without wasting our time, I'm going to recap back what is Wi-Fi. We know that when we say the communication, we do need what the medium, and the medium that we're using now for the Wi-Fi is light, and then for the input and the output, maybe we can call the transmitter and the receiver. So for this concept that being coined by the Harold Haas, that by using the LED, and LED will be our transmitter that will send or transmit data through light. We know that LED can change its brightness within the time cycle by its percentage, by the duty cycle. And then after we declare this our transmitter, our input, then we need to have another part which is called receiver, and I prefer to use photodiode as a receptor because it works very efficiently, better than LDR, even though LDR is also what react by the light. So by using the language of the binary language that being used for this communication, and we know as the LED light up, it will be considered as 1, and as if the LED is light off, considered as 0. So the data will be keep sending 101 101, depend on the how the LED flickers, since we know that the flickered LED that cannot be recognized or cannot be seen vividly by our naked eye. So that's briefly recap for this Wi-Fi. Next, for the problem statement for this project, for a long distance travel, most of drivers would prefer to use a highway as an alternative to reach at their destination. At a certain time, the driver may not notice there would be car from behind that will be approaching them with a high speed. Okay, besides, the distance between the front car with the rear car cannot be estimated accurately, or maybe you can say cannot be estimated by the front driver because his position in front, right? He doesn't have eye at the behind. And lastly, for the problem statement, the fatal accident in highway is increasing year by year caused by the collision of the rear vehicle. And sadly, in 2018, that Malaysia has been ranked for the third place with the highest accident in the Asian region. Okay, next, for the objective, what's my objective for this FYP is to develop a V2V communication in vehicle using Wi-Fi technology, which is success, and to develop the hardware and software interfacing for V2V communication using Arduino as a main controller, which is experimental analysis, also success. And next, the detection estimated distance between vehicle will display on LCD for both vehicles. This is not really good for me, but to accomplish this objective, I realized that certain tasks that I need to face. Okay, then after the objective, we go to scope implementation. Only apply for two vehicles which are rear and front vehicle. This what first study for me. And then second, distance or range for detection to communicate and transferring the data between the vehicle is within 5 meters. Last, the experiment of V2V using live technology will be done during night time, which is I'm not going to take a risk to do it at the daytime for the first time. Okay, for my literature review, I will choose the two best articles that really helped me to accomplish this project, which is by the what B. Shanmugam Priyan et al., which is the title of it, vehicle to vehicle communication using Wi-Fi technology by Android system, and they are quite study about the vibration based approach for automatic detection of pothole and speed breaker along with their coordinates. Sorry. The communication between the vehicle is based on the Wi-Fi technology. It is wireless technology which uses the visible light to transmit data at a high speed, which is 100 times faster than Wi-Fi. And this statement also being stated by the high educated professor or maybe doctor that's really study and do about this, and also being mentioned by the person who coined it for the first time about Wi-Fi, which is Harold Haas. And they also study the distance between the road or maybe the divider, I guess, and the car vary the ultrasonic sensor by the ultrasonic to detect the divider, the difference of the distance and transmit it to the car, maybe to the second car at the behind them, I guess, through the lights. Okay, for my second article, which is by Abdul Alim Jamali et al., which is the title is Collision Avoidance Between Vehicle Through Light-Based Communication on System. And they also prefer to use Wi-Fi because it has a high data transmission and reception, and they declare that the front vehicle will be read as a transmitter and the rear vehicle will be read as a receiver, which is different with my FYP that I'm putting the rear vehicle as a transmitter and what and the front driver or front vehicle as a receiver. And they also study which is the brake they make a brake as a input which is connected to the Arduino when they switch or when the brake is reacted and we connect it to the ground, then the LED will be up and transmit the signal of the brake status. So that's really impressed me how to make my 5 year success. Okay, now for my methodology structure. So after confirm that I'm going to take this title of the project, and then I realized that I have to search a lot of article and to read a lot about what is the fundamental of the Wi-Fi itself. After you get a knowledge about the Wi-Fi, then you can proceed what parameter and what process do you want to use to make your project success after what you found what the parameter you want to use and what kind of process you want to execute, and you then after that the step is to create a control method or formula. And then after you done with that step, go to the next one, which is the create basic one there. And for my FYP, I'm doing an experimental project which is not simulation. It quite hard for me because unfortunately we were being attacked by the COVID-19, so it also restrained me to go to the lab. But yeah, we have to win this war. After create the basic model, uh, of course we want the output of the project, and if the output was suitable or as what we want, then definitely go draft the report directly. If the output is not not good, not good or not suitable, or maybe error, so just go back to define or search another parameter that will be suitable with the process, or just proceed with the parameter, but the process is need to be changed. Okay, then this is my Gantt chart for FYP1 and FYP2. After that, the block diagram. We know for the transmission communication, it will be transmitter and the medium between the transmitter and the receiver. So, going first with the transmitter that I use as a processor, I guess. Arduino Atmega, which is the then how I want to send data through the Arduino by the serial print, which is serial print, which is the window of the Arduino itself. And definitely we have to have a power supply to make the Arduino to execute the program. And then the crucial part, you do need an LED to transmit data. And for the receiver, definitely have to have the brain of the part, which is I use Arduino Atmega, and the receiver of the light, I use a photodiode that will read the data that being transmitted by the LED. And power supply, of course, supply energy to Arduino, and then how do it display the data that being transmitted, maybe through the Arduino window, which is serial read, and the LCD itself. Okay, so this is my circuit for the transmitter and also the component of it that I just explain, not really explain, but for the transmitter circuit I do use something special, which is the IP120 Darlington is our my transistor. For the receiver circuit, yeah, we kind a lot of things that we have to make sure that the data is really go what is really being catched by the photodiode. So we need to have LED as a indicator, and also LM358 to decode, not to decode the. So for the equation that what we can calculate the distance between the front and the rear vehicle, which is this equation I work with one of our lecturer at Unica LMSI, which is Dr. John Jabara Devadasan, which is a much sir. So for the first step, we know that the velocity, if what if we derive it, we can get the distance, the distance, and if we want to know the point of the from one point to another point, so we just need to subtract it just like that. Therefore we can also compute that v is equal to v2 minus v1, and show uh, the derived part or derived distance. So despite of that, acceleration also work with the right of the, then we derive the a, so you will get the velocity. So also saying that the acceleration, if you want to know the acceleration, is equal to from the point of acceleration, first point, and then the second point of our acceleration with the time that we want. And for the second step, no, this is just for the fundamental for this equation. I guess this is a second step. The r is equal to what, in integrate v over dt. So you know that v from the previous also equal to v2 minus v1. So if in the case of the integrate, so we simplify it just like this. So if the what let's say if the velocity or each point, and then we reach to another point, of course in the real time it will not be same like a math question in SPM. So maybe we can just put something uh, some simple equation that we want to define as different from one point to another point with the time that we want. So if we after we what we sub the v2 as a 2 square, this is just example. So we can sub both v to the make it in t, and after that do a simple integrate, and you will get like this. So for the step 3, to we know on the second step, we can define that v1 also equal to v1 that from the point plus 1 minus v1, which is from the previous point, times t also goes same with the v2, that's velocity. So if we want to convert it, if you want to convert the velocity into words, into the distance, just sub the both v into the integrate equation that we are, and then it will be like this. After that we do what, we integrate the equation, and then we will get like this. V2 of t plus 1 minus v2 of t minus v1 of t plus 1 plus v1 t divided by 2, that's time with the t square, plus RO, so constant that it's depend on us what kind of distance we want. So in my case I want to use 5, and this is our final equation that can be applied in the Arduino. So do need to do some logic line to make this equation clear to the Arduino, and we get the best output as I want. So let's take all the equation. Next, data of result and discussion. So the data sheet that I will show later is the result of the data, but I use the data is in form of character, which is the character is in ASCII code if we use our laptop. So ASCII code definitely for the one character consists of 8 bits. Yeah, 8 bits, which is 1 each time, and that being running during the transmission from transmitter to receiver. It's like I declare from the earlier part. And then during transmission, there are three data will be transmitted at the same time due to observe the gradient of the graph. So what I want to find is, how about we send three data or three character in a same time in order to what to observe the gradient of the graph. Is it will be slightly ramping, or maybe just slightly increase, or maybe we can see it really in a straight line. Then this transmission is assigned with a parameter which is the distance from 30, 25, 20, 15, 10 and 5 centimeter. Meanwhile, the transmitter also divided into two type of color, which is red and white. So this is what to observe with which one have good response for their receiver. So this is my data sheet. You can say that what transmitter for the three input at the same time, and this is as a receiver. And now for the red data sheet, red transmitter three input at the same time, the red receiver at the same time. So this is the graph. I also declare that the maroon one is the white transmitter, and the red line is the red transmitter. And if we can see in this graph, we can see that the gradient when the data is being sent in the same time is not really being seen slightly increased, but it's almost in a straight line, so it's quite fast, since the time is also being calculated in the millisecond. So this for 30 centimeter distance comparison, and we can see the pattern. So I can see this, what we can see when the data is being transmitted from transmitter, and the receiver will follow the pattern from the transmitter, which is maybe slightly off of 1 second, I guess. Maybe that's something that can be improved for the next year. Also goes same, I can see that the gradient is not really, but not really menonjol lah. Saya terpaksa guna bahasa Melayu, maaf. But the pattern, just like I said before, the pattern, the receiver that copying the transmitter is quite same, even they are time bit off over the time. But I will show you something very interesting. Now for the 20 centimeter comparison distance, so same the previous one, but for the 15 centimeter, we can see that for the white section, when the white transmitter is giving the data, the receiver catch it really fast. It's, as we can see in the graph, that the white receiver line is really on the line of the transmitter. Meanwhile for the red, so but it's still good, have a, because the receiver have the same pattern with the transmitter, so we can know that there is no data loss, but just delay of the time. Now for the 10 centimeter and 5 centimeter, we can see that this I think it's really miracle that both white and red have react really fast like this, but when it come to 5 centimeter, the white is still consistent with what with catching the data really fast, but the red transmission being delayed, but the pattern of the receiver is the same with the transmitter. I think that good thing, but it just delay. It delay is better than data being lost. So for conclusion and recommendation, as a conclusion, it can be concluded that the result obtained are achieving the necessity that should has the transmission, communication, and the data that sent by the transmitter to receiver had no data loss. As from result and discussion, the most suitable and recommended type is the white LED, from my opinion. Uh, but this what? But this criteria can be overcome with the how much power of the your transmitters. Since I use three volt for both of it, but maybe you can the increase up the power of the LED itself, and the data show that it has slightly more accurate than the red, and the data will be more accurate when the distance is getting shorter. As for the recommendation, it is recommended for a further analysis that to increase the value of the data uh, that can be given in some time by doing study a lot about LED driver to prevent voltage fluctuating. So the problem that I face, cause the LED is click very fast until it can adapted with the data that I'm given, and so it will be data loss. That's why I only send 3 data in the same time, not 4, because the fourth data will be lost since I don't have the LED driver because of the voltage fluctuation. And in addition, by increasing the voltage of transmitter, which is LED, for getting better and accurate data in short time delay, as I said before, and advanced array coding must be applied in order to prevent from the data loss while processing the transmission. So this is my conclusion recommendation. So lastly, for the project output, which is FYP1, to develop hardware and software interfacing by using microcontroller to transmit and receive data or signal, which is achieved. And finally, FYP2, doing experimental data collection in data analysis. I think I do it great. So that's all from me. Thank you so much for spending my time. For spend your time for me to hear what I'm talking about my FYP project. So that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.